Today's show is sponsored by Okta, the leading independent identity solution. Okta provides best-in-class authorization so your customers and workforce can safely access what they need most right when they need it from anywhere. Organizations around the world trust Okta's Identity Cloud to sign in, authorize, and manage users, whether it's employees, contractors, partners, or customers. And with Okta's developer tools, you'll never have to build authentication again. Our customizable code blocks are flexible and future-proof with easy-to-use APIs and SDKs, so you can do less coding and more shipping. Okta is dedicated to building the most reliable, neutral identity platform because it means protecting more than a login. Identity is protecting people, their ideas, their work, their brilliance. It's protecting your future with confidence. Learn more at okta.com. That's OKTA.com.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. As we're recording this, it is the middle of June, and here in the United States, we're getting our first big heat wave of the summer, and specifically for us here in the Delp household, I have a Jeep, and I took the doors off the Jeep, I took the top off the Jeep, and because of that, I haven't driven it since. My wife and my kids are driving the Jeep everywhere and enjoying the great weather we are having this week. There is predictions, especially in the central parts of the United States, of some power outages and some other things coming up. So everyone stay safe out there, stay cool out there. As we jump into Cloud News of the Week, I completely admit, if I had to sum up the news this week in one word, it's meh. It's a slow week this week. But with that, let's jump into our first story. Our first story comes from our good friends over at DigitalOcean. They are starting a new program, and this is one of the more interesting ones this week, without a doubt. If you write documentation, more specifically, more along the lines of think tutorials and examples and things like that, for DigitalOcean, they will pay you, and they're willing to also make a donation to a charity of your choosing as well. I thought this was a really creative way to help kind of build up and supplement some of the areas where maybe they don't have the staff to do it, or maybe they have budget constraints, or let's be really honest, sometimes doing stuff like this just isn't super fun as well. And so if you're somebody out there that has a passion for this, a passion of teaching others and documentation, they are doing it on a topics basis for June when they announce this program. They're looking for tutorials on Node.js and also Prometheus as well. And if that doesn't rock your boat, then come back next month and there'll be new topics for next month as well. And with that, we're going to move on to our second story. Andreessen Horowitz is going into the publishing business. They're founding something called Future and Future.com. So, hey, they went and spent a bunch of money probably to go get the Future.com domain. But they think of this as longer form content. But longer form content, of course, where they're doing investments, but opinion pieces, future-looking pieces, and editorials. So this isn't like a news hub or anything like that. And longer form content, of course. They've had great success with their podcast and with their blog when they push out articles there as well. So the way I see this is just an extension out into longer form media. They have specifically said they're not going to go into video at this time, so just long-form written content. If you go check out it, again, it's future.com. It definitely feels, and they admit it, a bit of an MVP type of product. But this is where I'm a bit meh about the whole thing, because it just feels like a big blog. And I personally just don't read a lot of the long-form content anymore. So me personally, not my gig. But I know there are others out there. Everyone learns differently. Some folks like to listen. Some people like to watch. And of course, there are those that really, really like to absorb this kind of content, sit down, take some time, read these articles. Good opinion pieces, good authors. So if that is of interest to you, I suggest you go check it out. For our third piece today, Google Workspace is, I like to, jokingly say it came out of beta, but it is Google Workspace is generally available. It has, of course, been around for a while, but it is available to just about anyone now. So you can get a Google Workspace individual account. If you're a Gmail user today and you want to go all in on all of the other apps kind of in the Google ecosystem, you certainly can do that. And it is available, like I said, for just about everyone starting right now. And lastly, we have for news this week, our friends over at Redpoint have written an article that was an interesting read that is the figures that will move venture capital market for the next 5 years. And it goes into depth of the relationship between 10-year rates and venture capital investment and how much has happened each year. And, the long and short of it is, hey, if interest rates are low, cash is cheap, you get a lot of investment. And of course, as the rates go up, well, guess what? Now people aren't as willing to risk or put that cash at stake, and venture capital funding goes down. Short article, but a lot of information, very, very dense article. So if that is interest of you, it is in the show notes, and please go check it out. And with that, we're going to wrap up Cloud News for the week. And right after the break, we're going to be talking to Alex Ratner about the evolution of AI, and more specifically, data labeling for models and building applications as well.
Today's show is brought to you by CBT Nuggets. You know how much we value ongoing education on the Cloudcast. And CBT Nuggets is exactly what Aaron and I wish we had when we were trying to get our certification early in our careers. CBT Nuggets is all about bringing a personalized touch to learning about cloud computing, virtualization, networking, DevOps, and much, much more. Whether it's their hands-on labs with personalized coaching or the online chat functions that come up with every instructor-led course, CBT Nuggets' team of experts is always there to help you get the most from your training and your path to certification. You can check it all out at cbtnuggets.com/cloudcast and sign up for a free trial. You get access to the full catalog of great training, including virtual labs, quizzes, and other premium features completely free for the first 7 days. That's cbtnuggets.com/cloudcast. Today's show is sponsored by Datadog, a monitoring and analytics platform for cloud scale infrastructure and applications. Datadog provides dashboarding, alerting, application performance monitoring, and log management in one tightly integrated platform, so you can get end-to-end visibility quickly. Be proactive with your monitoring strategy and catch issues before your clients are impacted. Start managing the overall health of your environment with a free Datadog trial. Go to datadog.com/cloudcast for the free trial. That's datadog.com/cloudcast. And we're back. And folks, if you've listened to the show for a little while, there's always a couple of things that we really love. First and foremost, Aaron and I are just sort of technically curious. We love digging into new topics. We've been sort of fascinated with the AI space, the ML space, kind of data management for a long time, even though neither one of us can sort of scratch the surface on how the technology actually works. But we sort of love talking to the folks who are living behind it. And, from time to time, we find out about sort of some new breakthroughs that we think, really kind of knock down a big barrier that we've heard people have had problems with in the past. And so today, we're really excited to have a chance to talk to Alex Ratner, who is co-founder and CEO of Snorkel AI. And Alex, we're going to talk about the way that you guys are really kind of revolutionizing how to not only automate data labeling, but really kind of move this thing forward. So first off, welcome to the show. Great to have you on.
Thank you so much, Brian. Super excited to be on the show. And I don't know if we can claim to be, new and spry, because we've been around, I guess, since, 2015, hacking away at the same, core simple problem in some sense. But, definitely lots to talk about in terms of, both what we've been working on and also, just the general perspective about the space that it's born out of. Yeah. So super excited.
Yeah, and I mean, you guys are, Snorkel as a company now about 2 years old. Before we kind of dive into it, give us a little bit of your background, maybe some of the work that you were doing prior to Snorkel at Stanford, but also just give us a sense of kind of the founding team. We were kind of fascinated with kind of the breadth of, this group of people that you've brought together and kind of, how it all came together.
Yeah, no, so I mean, I think the team is the most special part of the whole Snorkel experience, both company and then back at Stanford when it was a lab project. But pretty standard story, at least as far as spinouts go. We started as members of a research lab. So one of my co-founders, Chris Ray, is a professor at Stanford. I worked with him as my advisor. We were looking around for a project. Said project, now spun out as a company. Became a little bit bigger and more interesting and sprawling than we had originally thought. So other people, joined on and took their own kind of unique views and components of it. And then, the five of us together became the co-founding team when we spun out in 2019. So that's the team story. But let me tell you the project story in brief. Yeah. I think so myself and Chris and the team, especially back in the research phase, thought of ourselves ML systems researchers. So, do stuff around the algorithms, the theory, the models, et cetera, but really very interested and anchored on this question of how do these machine learning AI technologies actually get to production? And what are the workflows around them in production? And what are the bottlenecks and the pain points? And that, always kind of anchored the research. And so we started, looking at a lot of the things that people traditionally get stuck on. And then circa 2015, we noticed this big sea change starting to happen. There were the rumblings of, this we were getting from we worked with a lot of the, big cloud companies who funded the lab and were and are great collaborators. And seeing this whole new class of AI machine learning model come out, often called deep learning or more broadly representation learning models. And basically coming out and being not just more powerful with some pretty amazing results, around that time, but also much more push button and much more actually commoditized and or just well supported by open source accessible platforms and frameworks and tech than ever before. So we saw the writing on the wall that machine learning was not only going to get more powerful. And we saw the obvious trends of increasing adoption and all the kind of supporting trends you need of increasing data availability and all that kind of stuff. But that it was also going to become that the traditional bottlenecks and pain points that you'd see companies, big tech companies throwing entire engineering teams at, the machine learning models, what's often called feature engineering of what particular aspects of the data the models look at, the algorithms that train and serve the models, the infrastructure they run on, were at least in a relative sense going to become much easier to use, more powerful, and less of a bottleneck. But there's no such thing as free lunch. What gives in return? Well, the change that was happening was that all these models that were both more powerful and in some sense easier to use because they did more automatically, or they do more automatically, present tense, are also much more data hungry. And so we saw this pain point shifting towards what's called the training data in machine learning. I'll get into that in a second. But basically, the data that fuels all machine learning was becoming the real pain point in the bottleneck. So at the highest level, we said, look, we think machine learning and AI in the next 5-10 years or couple of years is really going to shift to being increasingly about the data and increasingly being data centric. And so let's study it from the angle of the data. Let's build systems and algorithms and formalisms around what you do about the data. And specifically this thing called the training data. So in machine learning, if you want to, let's take a supervised learning task. So if you want to help hospital systems classify chest x-rays for which ones need to be read urgently, or help a telco classify network traffic anomalies, or help a bank classify contracts or call transcripts, or pull information from private company financials or forms, or help underwriters make decisions around insurance, in the insurance space. All these things are applications that are served on top of our platform, Snorkel Flow today. They're all basically, consist of an ML model having to make a decision. And the way that machine learning or AI models learn to make a decision is that they see lots of historical examples labeled with the correct decision or label. And that's called training data. It's kind of like like learning to take the SATs by seeing lots of questions and answers.
Right.
So we basically said, look, the training data used to be the small thing, but now these modern models are just beasts that require massive training sets. And the ML community is treating this like it's some kind of, third-class citizen of the process, this pre-processing step that you just kind of download a labeled training set and get going. But in the real world, labeling all this training data, collecting it, labeling it, cleaning it, managing it takes, quarters, takes weeks to person months, even person years of trained expert time in many settings, and is often the bottleneck in actually using AI or ML. So we looked at this and we said, look, we think training data and more broadly training data management is going to be, the pain point and the center of AI moving forward, or at least in many use case settings. And let's actually try to build a platform that, puts table stakes on the models being taken care of, the rest of the infrastructure. We figure there are lots of smart people out in many in the open source doing great work there. Let's build a system that focuses on the data as the center of the, iterative process of building an AI application. So that system was and is Snorkel. And that was the first key idea. And the second key idea is, okay, if data really is where it's at, let's come up with a better way to deal with it than just having humans label it one by hand, which is kind of the legacy approach that still a lot of machine learning rests on. And let's instead, and so you take one extreme, which is, there's lots of money still being spent on it, especially in the self-driving industry, lots of, marketing and hype and venture dollars behind it, but it really is a decades-old legacy approach that can work sometimes, but is just a non-starter in many settings. Especially when you need trained experts to do the labeling, you have privacy constraints, your data is changing all the time, which covers a lot of the real world. So we said, okay, we're working with, government agencies, big tech companies with rapidly changing data, doctors, lawyers, all these folks who just, that's not an option. So we can't do that. Then on the other extreme, you have people in the AI space and, hundreds of vendors these days who will tell you, hey, we have a push button auto magic solution. And, we scratch that as a goal right away because we just don't believe that you fundamentally ever can or want to take the human out of the loop.
Right.
So what we were left with was, how do we put the human in the loop with it looking more like a software development process? Sit down, write some code or push some buttons, build a training set and then a model in an afternoon. And so that was the idea behind Snorkel in a nutshell, of labeling data programmatically and making it really fast and iterative and easy for humans to do that, and having that be the process, essentially having AI turn into a process of programming your data more so than anything else.
Yeah.
And it was a science project idea at first. That's why we chose a silly name like Snorkel, because I actually had a cold at the time, and my advisor Chris insisted that he thought it sounded funny when I said it because I had a terrible cold, and I said, well, what the heck? This project's going to be dead in a week. He said, I want to consign you to being on stage saying that word in your especially nasal tone for years. And I said, that's nonsense. Again, it's going to be done in a week when the project falls through, like most research projects do. But it ended up hitting a real pain point that was resonant even back then amongst people. We started having tons of people just coming to our office hours saying, hey, training data is exactly our problem. What's this solution you're talking about? And, became, opened up a lot of interesting avenues to speed up AML. So that's how we got here today in a nutshell.
Yeah, no, it's interesting. And the labs you're talking about are the Stanford, AI labs, for those of you who are
sorry.
Along. No, it's okay. It's interesting. It's funny. Your colleague sort of, wanted to make fun of you for a name. I know I did that one time. I had an internal project that we called Mackinac, because I grew up in Michigan, and the Mackinac Bridge was this thing, and it was just funny to me to watch these folks from Boston with their accents try and say this word. So I can appreciate that. Now, let me just.
I love that.
I want to put something in context just so I can, because we get a chance to talk about a lot of topics, and it's always good to see if it's similar to something else. If you've been in the database world, or even if you were like in the storage world, and you were ever dealing with stuff that was like data lakes, or you were merging databases, or you're merging data sets, we always sort of live through this problem of what people used to call ETL or extract, transform and label. Is there a similarity in sort of what, I don't want to put it in the same bucket because ETL, has a certain place, but like, is it sort of similar in that, yes, we have tons of data, but the data without some sort of context around it is somewhat difficult to have a starting point? Or is this, what you do with training data labeling a very different sort of domain?
So I think there are
problem space, if you will.
Yeah, I mean, so in some ways very different, but there are a lot of strong connections. And actually, funnily enough, so I think that the first course that Chris and I kind of rewrote and taught together was the intro database course at Stanford. That came from database background and still think about that a lot.
Yeah.
And so we actually were thinking about ETL a bit. We were thinking about the idea of having these kind of ETL functions that now we call them labeling functions that would kind of help clean up this data, and then you'd have a model that would learn to do it more capably from them. So there was definitely some of that inspiration. And then there's another connection, just so it's not confusing if people are listening along, but also looking at some of the stuff we've worked on over the years or through the company. We often use, or rather customers often use Snorkel Flow to build information extraction models. So one of the use case types, and we can get into this later if you want, one of the use case types that is, that is most applicable because it uses, and it really needs these very data hungry models, is anything dealing with text, with unstructured text,
Right.
Pulling stuff out. And so Snorkel Flow both has kind of some connection to the idea of, yes, data is useful, but not until you add structure to it, for example, labels. But also, so as not to confuse, the other connection point is that Snorkel Flow is actually used to power many AI applications that are basically doing ETL or information extraction type workloads these days.
Okay. Cool. So
things like pulling clauses out of contracts at a bank, imagine, or tagging entities in news articles, things like that.
Yeah. Okay. So you've mentioned Snorkel Flow. For those of you listening along, Snorkel Flow is sort of your core platform, your core technology. Give us a sense of what's under the covers of it, and what's it actually doing in terms of creating this ability to label mass amounts of data and make it useful for these models.
Yeah, so Snorkel Flow, and I'll stay high level to start, but Snorkel Flow is basically a platform that's meant to take this process of building machine learning models and AI applications, and again, all starting with building the data that they rely on that fuels them, and make it, in a nutshell, look more like an iterative software development process than this kind of 80 to 90% upfront, just hand labeling exercise. And so Snorkel Flow supports that entire iterative loop of, actually labeling data can be by hand in the platform, but most centrally programmatically. Yep. By letting users write what we call labeling functions. Basic idea is that rather than say asking your, legal associate at a bank or your doctor friend to sit down and, label 100,000 contracts or 100,000 electronic health records, have them write, heuristics or bits of their expertise, like, look for this keyword or look for this pattern or look for this, et cetera. Kind of like a bridge from old, expert knowledge type input to modern machine learning models, using one to power the other. So Snorkel Flow is an IDE basically, and has a no-code UI component as well that lets people either via code or by pushing buttons for even non-developer subject matter experts, say, to programmatically label their data by writing these labeling functions, and then uses a bunch of modeling techniques, a lot of which was actually the work that the co-founding team and I did in our kind of thesis work around how you take a bunch of programmatic data and clean it up and turn it into a final set of clean training data for machine learning models. And then actually in Snorkel Flow, you can, basically push button train, best in class open source models. You can then analyze where they're succeeding or failing, and then use that to go back and iterate on your data. And there's a Python SDK throughout the whole thing. So many of our customers will mix and match. They'll use Snorkel Flow to, create the training data set and then train a model on some other system, et cetera. But what Snorkel Flow aims to support is this basic iterative development process where, rather than just spending months to label a training set once and then being stuck with it and having to throw it out and start all over again, if anything in the world changes, your upstream input data changes, your downstream objectives change, making it, again, more like an iterative process where you push some buttons or write some code that labels data, you compile a model or train it, but you can think of it like compiling, and then you go back and debug by iterating on your data.
Yeah.
So everything centers in Snorkel Flow around looking at your data and iterating on how it's labeled to improve model performance.
I'm curious. So you mentioned in there there's a Python SDK, which for anybody who sort of works in data science, data modeling, right? Like Python's sort of your language, to Frank, sort of the language you use, or R, there's a couple of them, but that's sort of the language that kind of how you do your programming. But I'm curious, like in today's world, do data scientists sort of consider themselves programmers, or is there still sort of look, I work on the numbers, I'm good at sort of building models and the numbers, but I don't think of myself as a programmer? Like, how do you sort of bridge those two worlds together, or do you not really have to bridge them together? Like, how much does a data scientist have to go, I have to focus on numbers and models versus I have to focus on like programming something to do stuff? Like, what's their world look like today?
It's a great question. I mean, I think that I think I have been, or currently I'm part of like 4 or 5 different data science institutes or something. And I don't even still know. I mean, the data science is such a broad umbrella term. There's so many different varietals of us and types. And so I do think there's a very broad spectrum of, the data scientist that's, kind of an ML engineer and just, loves writing code, to the one that, to your point, really just wants to, push some buttons and get back to the numbers and the modeling and the outcome. And, we definitely, try to kind of support the range through a layered approach. We have a Python SDK, but on top of that, we have a no-code UI that allows you to write these labeling functions without writing code. So, for example, if you're trying to train a contract classifier in Snorkel Flow, you can write labeling functions based on clicking on keywords or pressing buttons with kind of templates for types of patterns or signals you want to look for. So, we try to support basically, if you want to move fast and you're a non-developer or you're just not looking to spend time there, you can just do it in a push button way. But then if you want to go and customize or inject custom logic or really get, creative, you can always fall back to the Python SDK. And so, I mean, I think a lot of the, what we were trying to accomplish from the very beginning was, kind of raising the abstraction, level at which you're interfacing with and programming your machine learning model or your AI application. And the first step is the hardest, right? If you think of the way that hand labeled training data is kind of like the machine code, or really actually, just you think of it as like the ones and zeros, literally, for a binary classification case. A lot of the effort behind the Snorkel project and the company is was just getting from that layer to the layer of assembly language, say. But once you get there, you can build all those layers on top, and you can go up the stack and down the stack according to the application of the user type. Right? Actually, my co-founder Braden, who also did his PhD around Snorkel related stuff, had a paper actually on how you could use natural language inputs. You could explain in natural language, just speaking to the computer, why a certain data point should be labeled a certain way, and then use off-the-shelf semantic parsers to parse that down to code, which then would get dumped into Snorkel. So basically, once you make this leap from labeling data by hand, kind of the zeros and ones, to labeling your training data with code, then kind of the sky's the limit in terms of building layers of abstraction on top of it. And that's actually a lot of what the company, does and has been doing over the last 2 years is building a flexible interface through our platform, Snorkel Flow, for different data types and use case types and user types.
Yep. Well, and I think you really kind of answered my question. And the reason I brought it up was, on one hand, you have this you have this, language level SDK in terms of Python. You can get into, some pretty granular level stuff. And then you have, on the other end, you've got Application Studio, which like you said, is this sort of low code graphical way of, building templates and building applications. And I was like, there must, I think sometimes there's this perspective of like, there's one profile of a data scientist. And I think what you really highlighted is, it's like a lot of things. There's sort of a spectrum of, those that specialize in sort of, one part of the job, others that don't care about it and want certain things to be easy. And so that was useful, because I think sometimes, like in my head, I'm thinking, okay, data scientist is certain sort of tasks the same way you might say like, oh, okay, they're a Java developer. So they, there's a tool set that they always use. So that was super helpful.
Yeah, and it depends on the problem and stuff too. I mean, the other thing also that I think goes underemphasized in the AI space, big kind of, point number one, and I don't think it's that avant-garde anymore to say it. It was maybe more back in 2015 is, hey, AI is about the data, not the models or the algorithms, which I think, fewer people will find a controversial statement today, even if it's kind of, phrased in a somewhat reductive way. But the other thing that I still think is underemphasized in practice is the necessity of looping in what we often refer to as subject matter experts into the process. And so I think, and I won't ramble here too long, but just for some perspective, and this is actually the very first DARPA funding that the Snorkel project ever had, was specifically about looping what they call SMEs in the government, subject matter experts. Mm-hmm. Our original partners were some genomicists at Stanford. How do you loop them into the process of AI in a better way than just saying, hey, go label data for 8 months for me, please. This idea of how do you get subject matter expertise from a human's head into a scalable machine format has been the focus of AI for, decades. But, the answer of modern machine learning today for the last, 5-10 years has been, okay, just sit them down, have them label data points one by one, nothing else. They've got all this rich domain knowledge, a doctor, a lawyer, a cyber analyst, a network technician, an underwriter. Throw that all away, just have them literally just, give zeros and ones labeling data. And that's a nice abstraction, and it has been actually a very productive one for the field, because that means the ML engineers can totally abstract away the messy realities of real world data and real world subject matter experts and just focus on optimizing, a fancier model architecture. But I think we've reached a point where it starts to become silly and impractical to have this wall between the subject matter expert and the data scientist. So all that is to loop back and say that a big focus of Snorkel Flow is about making these interfaces and this process accessible to a non-developer who's, a legal associate or an underwriter or a network technician to drive the process too. And that's another motivation behind the kind of, layers, including no-code UIs.
Yeah, no, and that's super helpful, because I think, first and foremost, if you don't know what the business is ultimately trying to accomplish, since most of these are,
exactly.
very business driven, you're right, it's very abstract. And but I was curious, you sort of led me into my next question, which was, do you go into this with sort of a set of use cases that you're like, look, we're pretty confident that there's going to be a lot of companies that have these common use cases? Or have you found that, as you dig in with early customers, you start to work with their subject matter experts that you're like, oh, okay, that concept that you're talking about, whether it's in banking or, government or whatever, like we can apply, like that looks very much like this. So like, have you been sort of driving use cases? Have customers been coming to you with a different set as you understand their business? Like which end is, is the tail wagging the dog wagging the tail kind of thing?
It's a great question. I'll skip the who's wagging who metaphor, so we don't I don't reflect too unfavorable on ourselves. But I'll use a sanitized go-to-market terminology instead, and I'll say that we've been mostly doing an inbound motion in that had a lot of great collaborations and some visibility during the Stanford days, and we've had some really awesome folks reach out, and even more than we've been able to, much more than we've been able to onboard, given that we're trying to, like an early company, be absolutely committed to customer success, and therefore, kind of onboard in batches. And there, we've been somewhat flexible around what use cases we go with. And again, Snorkel Flow is a development platform. Again, primarily for data scientists, but other stakeholders as well. And it can be used pretty flexibly. But we're increasingly starting to do more targeted outbound and more kind of guiding to at least to land with specific use cases that we have more robustly templatized.
Yeah.
And there's not too much, mystery around which use cases you choose. One of the nice things about ML is they're nice, good abstractions, right? Like, document classification, information extraction. These are kind of standard things that apply to lots of different business use cases that, we've worked on for years. So we kind of know what they are. But we've increasingly been trying to kind of land with ones that we have nicely templatized so that, it's faster for us, faster for the customer, more self-serve. And then, what we find is then, once they get a win with one of those, our customers then, fan out and, build new applications that we hadn't even thought of using the basic primitives on the platform. So it's kind of that, a very, I'm not saying anything too novel. It's a kind of land and expand, but it's landing with more kind of templated, specific use cases, and then expanding based on just, data science creativity on the customer's end. And I think, the other heuristics that we often use, this is not an exclusive criteria, but I think, one thing to note is that we've done, when you're in academia, you do a breadth first search. We've done everything from like genomics to self-driving to ad spam in different Snorkel deployments. But at the company, we're most interested in a lot of these settings that really, are 0 to 1, even for the world's largest organizations, right? We work with, 2 of the top 3 US banks, a bunch of government agencies, a bunch of Fortune 50 companies in different verticals. These are very sophisticated, well-resourced companies. But a lot of the use cases that we start with, they're still blocked on the data, right? We did a paper with Google. We did deployments in some of their most, significant by revenue applications, where they have infinite budget, basically. But you're often still blocked on the training data, especially, and I kind of mentioned this before, but especially when you have data that's private, you have data that you require very highly trained experts, a doctor, a legal analyst, a network technician, et cetera. And when you have data that's changing all the time, and as much as you hear about streaming in the database world, and you hear about it theoretically for decades in the machine learning world, most of machine learning is still done in batch, and most conceptions of training data sets are still of these like static, assets. Like the benchmark training data sets that the last decade of ML progress has been predicated on haven't changed in a decade.
Right.
If you've heard of something called ImageNet, that's what kicked off a lot of the exciting progress. A bunch of, cats, dogs, hot dogs, kind of images like that labeled that a lot of the state-of-the-art image models kind of got trained on and caused this big explosion around, image modeling with modern architectures, modern machine learning architectures. It took a couple years to create, even though it didn't require experts or private data. It hasn't changed since. So a lot of machine learning is based around this idea that the training data set is this fixed thing. But in the reality of really any data science project or business I've ever seen, your data is coming in, is changing constantly. There's what's called distributional drift of just, let's say you're scanning news articles, like, for financial crime, right? What happens when people start saying stonk or diamond hands?
Right.
And your model's never seen that before. How do you adjust to that? But also, what if there's an upstream team that does all the, is doing the data pre-processing, and they change a little something that something as small as that can throw off your model. And then what if your downstream line of business team that's the consumer says, I want to tag 10 types of entities instead of 7 this quarter. Yep. And so the modern conception of training data, which is the bedrock that all of ML rests on, is completely just unprepared for this. It's just, okay, great, relabel everything. And so even for the largest organizations, this ends up being a 0 to 1 blocker. And Snorkel Flow doesn't push button automatically solve this, but it means you can sit down for a couple hours or a day or two and adapt just like you would with any other production software outside of machine learning, versus having to basically start from ground, from square one every time. Right. So that kind of gives a sense of maybe some of the use cases that we end up finding most resonant and going after to start with.
Yeah, no, and that makes a ton of sense, especially when you sort of define it as 0 to 1. I mean, you think about, you can go to the companies in the Valley, the Facebooks and Googles, and they've been essentially data companies forever. So they've thought about these flows. You go to the banks or you go to insurance companies or whoever, like they've, number one, they've sort of just coming out of a decade of people telling them to build data lakes because they had hundreds of disparate data sources. But organizationally, they're not designed as data companies. So yeah, I mean, them getting from 0 to 1 seems, in 2021, like how can that be? But if you think organizationally and historically where they'd been to, it makes a ton of sense. And they've been sort of begging for people to go, look, help me with some of these problems that, are just big kind of boulders to push up the hill. So that makes a ton of sense as to kind of how it gets there.
It's also, and just to put in a word for, I mean, certainly, our early customers, like, I think what actually makes this pain point, and I think many around it in kind of the ML ops and data management space, so painful or so resonant is the fact that you have incredibly smart people, and you have these, a lot of these organizations really have put big bets down on becoming AI first, have just incredible teams, incredible technology, incredible infrastructure. But then they're blocked on the data, or they're blocked on some ops consideration, and so that actually makes it more painful because you have all the pardon me, raw talent, all the infrastructure, all the tools. I mean, many of them are out in the open source, effectively come on, but you're stymied by waiting for your line of business team to label 100,000 more contracts over 2 quarters before you can literally even turn the crank. And so that's the reality we often see today. People have already put down tons of chips on AI, and then when they hit this wall of data, and again, I think that's a Snorkel story, but it's also for many of the other complementary or other techniques or companies in the space in the kind of data management meets ops meets machine learning space. When you have that much talent and you're revving to go and you put your chips down and you're blocked on something like this, that's a real pain point.
Yeah, no, it makes a ton of sense. I want to ask you 2 real quick questions before I let you go, because I know you guys are super busy. We've talked about it's a development platform. It's a piece of a bigger puzzle, right? There's modeling technologies. Is there kind of a standard stack, or is the stack kind of flexible enough because there are so much stuff that's done with open source and the open source communities kind of make things fit together? Do you see a stack? Is it, like on top of Snorkel? Is it TensorFlow? Is it certain other things? Or is it really kind of depend on the problem in the industry?
It's a great question. So, I mean, we have our standard, Snorkel stack diagram and stack that includes, a lot of the kind of, bedrock, platforms and open source repos, for models, for frameworks. I won't, answer PyTorch versus TensorFlow versus MXNet. Sure. We're flexible. I'll stay agnostic there. But all those things kind of are part of Snorkel Flow, along with some of our open source code over the years that they're all component libraries. And then in turn, our whole bet with Snorkel was that the open source and the tooling around models and infrastructure was just exploding, especially out in the open source. So we think of interoperability as a first class part of our design. A lot of that is we have this Python SDK that anyone who can write Python can put stuff in, take stuff out, mix and match components. And I think, the experience that most people who go into the enterprise will find, especially in a booming space like this, is that, you have to play nice with existing stacks and other tool sets. And so we're pretty flexible on that front. We care. Our whole vision from the very beginning has been to define a new workflow. So we actually do have a fairly end-to-end platform, but people can mix and match very easily. We have some customers who, will actually train models in Snorkel Flow, but just to get their training data good enough. And then they'll export their training data and they'll go, train their own custom models. We have some customers who will, train models, but then export them and serve them on other ML platforms, and then go back to Snorkel Flow to modify them. That's actually our current, preferred kind of pattern. But we're very flexible in general.
Yeah,
and I think you have to be in enterprise AI today.
Oh yeah, no, absolutely. One last question before you go, since you've been through sort of all of the school, if you will, through PhD and everything. There's always lots of folks who say like, "Hey, I'd like to get my kid into this space that could become, data science and so forth." Like, beyond the stuff you take in high school, like what's the modern path? Is it math? Is it what types of math or other things would somebody take if they kind of wanted to go down the path to be like, I would be productive in this domain? Has it changed a lot? Is it certain core things they should be focused on?
Yeah, a great question. And I'm gonna hope my dad never listens to this, because he's just gonna get another "I told you so" about all the things that he told me to take in college and I didn't, and then had to make up later. But I think I think a lot of people have lots of great answers on this that I'll just be parroting and won't do justice to. But I think statistics, first of all, is something. It'll sound crotchety and old school to say this, but again, machine learning is at its base just counting. Mm-hmm. And we have better and bigger scale and fancier ways of counting, but that's what's at the core of it. Understanding the fundamentals of statistics, they don't map as easily to some of the modern deep learning techniques that we're still on the academic side, as a field trying to understand. But that kind of intuition, I think, is very important. And so statistics and linear algebra, which would have been the classic pillars of a lot of the old ML approaches. Now, sometimes people say, "Oh, you don't need that anymore." I still think, I'll put in a vote that they're still very important. Mm-hmm. I also would put in a pitch for just anything, if you're talking, especially, high school, undergrad, et cetera, but at any time in life, anything that emphasizes just, written and verbal communication. I know that's a very generic thing to say, but whenever you have a space that is, as complex and noisy and teeming as the AI space is today, right? Just communicating what the heck you're trying to do and how you relate to other things. And I'm not saying I did a good job of it, but, that is just commensurately more meaningful, in my view. So I'd say that's something, that's one of the generic answers I give, especially when talking to at any point. And then I think beyond that, just like being able to code, the great thing, is that, the bar to start playing around with machine learning tools out in the open source has never been lower. It's still tough, but if you can teach yourself to code a little bit and then just go and hack around the open source, it's never been a better time to just, take a Coursera course, go to, one of the many great, resources for kind of, open source machine learning frameworks, and just kind of play around and learn on your own too. So that's a wonderful facet of this space today.
Yeah, no, that's it's good advice, and I'll double down on the aspect of communications. I know sometimes the folks that are very, very technical go, well, that's a secondary thing. But like you said, at the end of the day, no matter how good your numbers are, if the people who then have to go implement it or fund it or whatever can't understand it, it's just a bunch of numbers and stuff. So excellent advice, Alex. I have learned a ton. I know we've kept you probably a little longer than we expected, but this has been great. Hopefully folks, we're always trying to sort of peel back the onion of what makes up successful AI, where's the industry moving, and we're excited about the stuff that you guys are working on. So thanks so much for the time today. Folks, with that, I'm going to wrap it up.
Thank you so much.
Yeah. Folks, with that, I'm going to wrap it up for, again, want to thank Alex for the time. For myself and Aaron, we always want to thank you all for giving us the time week in and week out, for listening, for telling a friend, for helping us grow the show, and giving us feedback on Apple Podcasts and everywhere else you listen to. So with that, I will wrap it up, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.